Now, before we dive really deep into Node.js, Express, databases, and more, it's important to get a good understanding of backend development in general, because that's what we actually use Node.js for in this course. So you're going to learn things like how the web works, the request-response model, HTTP, TCP/IP, static versus dynamic websites, what APIs are, and much more. And I hope that with the sections, some of the things that we did in the last one will then start to make more sense. So our goal is to develop back-end applications with Node, and therefore it's probably a good idea to get a basic understanding of how the web actually works behind the scenes, right? And this is going to be a really full-packed lecture, and so let's dive right in. Now, in order to get a better understanding of how the web actually works, let's start by asking the question, what does actually happen each time that we type a URL into our browser in order to open up a new web page, or each time that we request data from some API, which is actually quite the same, and so let's just focus on a simple website example here, okay? Well, the most simple answer is that our browser, which is also called a client, sends a request to the server where the web page is hosted, and the server will then send back a response, which is going to contain the web page that we just requested. And this process is called the request-response model, or also the client-server architecture. And everything that we're going to talk about in this section revolves around this fundamental concept. Okay, but let's now take this one step further, because this is probably not really new for you at this point, right? So let's say that we want to access Google Maps by writing google.com/maps into our browser as the URL. And every URL gets an HTTP or HTTPS, which is for the protocol that will be used on the connection. And we're going to talk about this a bit later in this video. Then we have the domain name here, which is google.com in this case. And also after a slash, the so-called resource that we want to access, and in this case, /maps. Now, what you need to know here is that the domain name, like google.com, is not actually the real address of the server that we are trying to access, but just a nice name that is easy for us to memorize. So we need a way of kind of converting the domain name to the real address of the server, and that happens through a DNS. So DNS stands for Domain Name Server, which are special servers that are basically like the phone books of the internet. So the first step that happens when we open up a website is that the browser makes a request to a DNS, and this special server will then simply match the web address that we type into the browser to the server's real IP address. Alright? And actually, this happens through your Internet Service Provider, or ISP, but the complete details don't really matter for us, okay? What you need to retain from this part is that the domain is not the real address and that a DNS will convert it to that real IP address, which a browser can then call after it being sent back to our browser. So this is how the real address looks like. So it still has the protocol, but then comes the IP address and also the port that we access on the server. And the port number is really just to identify a specific service running on a server, and so you can think of it like a sub-address, okay? Remember how we listened to port 8000 on our web server when we set it up in the intro section? That is exactly what this port is, okay? Also, please note that the port number has nothing to do with the Google Maps resource that we want to access. That resource will actually be sent over in the HTTP request, as we will see in a moment. Okay, and this wraps up the first step. So once we have the real web address, a TCP socket connection is established between the browser and the server, which are now finally connected. And this connection is typically kept alive for the entire time it takes to transfer all the files of the website. Now, what are TCP and IP? Well, TCP is the transmission control protocol and IP is the internet protocol. And together, they are communication protocols that define exactly how data travels across the web. So they are basically the internet's fundamental control system, because, again, they are the ones who set the rules about how data moves on the internet. And don't worry, we'll learn a bit more about TCP/IP a bit later in this video, okay? Anyway, now it's time to finally make our request. And the request that we make is an HTTP request, where HTTP stands for Hypertext Transfer Protocol. So after TCP/IP, HTTP is yet another communication protocol. And by the way, a communication protocol is simply a system of rules that allows two or more parties to communicate. And in the case of HTTP, it's just a protocol that allows clients and web servers to communicate by sending request and response messages from client to server and back. Okay? Now, a request message will look something like this. So the beginning of the message is the most important part, called the start line, which contains the HTTP method that's used in the request, then the request target, and the HTTP version. So about HTTP methods, there are many available, but the most important ones are GET for simply requesting data, POST for sending data, and PUT and PATCH to basically modify data. So you see, an HTTP request to the server is not only for getting data, but we can also send data. Alright? Now, please don't worry if all this sounds a bit too much for you at this point. We will of course use this stuff throughout the rest of the course, which is actually the whole reason why I'm telling you this, right? Anyway, about the request target, this is where the server is told that we want to access the maps resource in this example. Remember that? So we had /maps in our URL, and now it's sent as the target in the HTTP request, so that the server can then figure out what to do with it. And if this is empty, so if it was just a slash basically, then we would be accessing the website's root, which would be just google.com in this example. Then, the next part of the request are the request headers, which is just some information that we send about the request itself. And there are tons of different headers available, like what browser is used to make the request, at what time, the user's language, and many others. Finally, in the case we're sending data to the server, there will also be a request body containing that data, for example, coming from an HTML form. Okay? So that is the HTTP request. Now, of course, it's not us developers who manually write these requests, but it's still extremely important that you understand what an HTTP request and also a response look like, because you will be working with them a ton. Okay? Also, I want to mention that there is also HTTPS, as you probably know. And the main difference between HTTP and HTTPS is that HTTPS is encrypted using TLS or SSL, which are yet some more protocols, but I'm not gonna bore you with these. But besides this additional encryption, the logic between HTTP requests and responses still applies to HTTPS. Alright, so our request now hits the server, which will be working on it until it has our website ready to send back. And it will send it back using, as you can guess, an HTTP response. And the HTTP response message actually looks quite similar to the request. So also with a start line, headers, and a body. The start line has, besides the HTTP version, a status code and a message. So basically to let the client know whether the request has been successful or not. This 200, for example, means OK, and the one that everyone knows is status code 404, which means not found. And so this is where this 404 code that you already knew comes from. Okay? Then the response headers are information about the response itself. So just like before, and there are a ton available, and we can also actually make up our own headers. Now what's different about response headers is that it's actually the backend developer like you who specifies them and sends them back in the response. Alright? Finally, the last part of the response is again the body, which is actually present in most responses. And it's also the developer who specifically sends back the body in the response. And we actually already did this back in the intro section using response.end. Remember? And the body should usually contain the HTML of the website we requested, or for example JSON data coming back from an API, or something like that. So we talked in great detail about the most important parts here, which are the HTTP request and the response. But in our imaginary example, we only just did one request to google.com and got one response, right? However, if it's a website that we're trying to access, there will be many more requests and responses. And that is because when we do the first request, all we get back is just the initial HTML file. That file will then get scanned for all the assets that it needs to build the entire website, like JavaScripts, CSS files, image files, or other assets. And for each of these different files, the browser will then make a new HTTP request to the server. So basically, this entire back and forth between client and server that I just explained happens for every single file that is included in the website. There can, however, be multiple requests and responses happening at the same time, but the amount is actually limited because otherwise the connection would start to slow down. Okay, and then finally, when all the files have arrived, the website is rendered in the browser according to the HTML, CSS, and JavaScript specifications that you might already know. And now, as the final piece of this puzzle, let's again talk about TCP/IP and figure out how this request and response data is actually sent across the web. Okay? So we said before that TCP and IP are the communication protocols that define how data travels across the web. Now, I'm not going to go into a lot of detail here, but here is what you need to know. First, the job of TCP is to break up the requests and responses into thousands of small chunks called packets before they are sent. Then, once they get to their destination, it will reassemble all the packets into the original request or response, so that the message arrives at the destination as quick as possible, which would not be possible if we sent the website simply as one big chunk. So that would be like trying to go through dense traffic with like the biggest bus that you can imagine. So not a good idea. Now, as the second part, the job of the IP protocol is to actually send and route all of these packets through the internet. So it ensures that all of them arrive at the destination that they should go, using IP addresses on each packet. And again, this is just a very broad overview of what really happens behind the scenes of the web, because that is actually way too much information than you actually need in order to become a great backend developer. But I hope that you still found this information useful and interesting, and also not all too confusing. Now, in the next video, we will then actually do some HTTP requests so that you become a bit more familiar with the protocol. So after the kind of heavy theory lecture, let's now actually see HTTP in action and do some requests and take a look at the responses we get using our browser's developer tools. So I'm using Google Chrome as my browser and I'm here on udemy.com. So just go to udemy.com and then open your developer tools. And I'm using Command Option J for that on my Mac. On Windows, it's probably Alt Control J, or just right-click anywhere on the page and then click Inspect. Okay, just in case you're not familiar with the DevTools. Then what we're going to do is to head over to the Network tab and then click here on Disable Cache. That's important because otherwise you might be loading the page from your computer because you've been to udemy.com before. Okay, so let's now reload the page so that we're gonna kind of record the network activity here in this Network tab. So reload this. And so now here we can see all the requests that are happening on the page. So as I told you, there are going to be a lot of requests for all of the elements that are on the page. Now, if we're going to the top here, the first of all is actually udemy.com. And we can see here the status code, which is 200. As I said in the last lecture, that means okay. So everything went right. Then the size and the time it took to download this resource. But then we also have all of these other resources here, like the CSS files you see here, some images, JavaScript files, like you have here. And all of these were actually initiated by the index, so by the root page. Okay, so we have udemy.com, and that one will then request all of these assets. So that is the index, so it doesn't have an initiator, and all of these here were requested by the main udemy.com. Now, if we click on one of these resources, and let's do the actual udemy.com first, here we can get some more information about the request and the response. So first, the request, which is actually at the bottom, and you see that the request was made to udemy.com. We did a GET request, and the path was just the root path, just like I explained you in the last video. Okay, then we have a bunch of headers. So this here, for example, means that the page was compressed using this gzip. Down here you have a header for setting some cookies and a bunch of other headers, and which we will talk about later on. So this is the request, and then the response also has a bunch of all of these headers. Okay, so we can see when the response was actually sent. We can see a bunch of cookies and the status code here as well. So that's where the 200 status code comes from. And again, a bunch of other headers that we're going to talk about a bit later. Okay, and the same, of course, we have for all the other assets that were downloaded. So the response and the request down here. And this time we actually see that the root here is still udemy.com, so what they call the authority here, but the path is then all of this, so this location here where the CSS file is located. And if we actually now browse somewhere here on this page, let's say to the web development courses, well, then let's see what happens here. And so here we have this page, which is the web development resource. Okay, so basically this piece here of the URL. Remember that this is called a resource from the last video. So if we click on that, we will actually see that here again. Right? So we have again udemy.com and then /courses development /web development. So that is the path where the request is going to. Here on the left side, we can also like preview images. For example, this logo here. When it's an image, we can see the preview. We can see the response a bit better. For example, in this one here, we can actually see the HTML response that came back. So instead of just seeing the headers like we did here, we can actually see the response as well, and a nice overview of all the cookies that were set in this request. Now we didn't talk about cookies just yet, but again that's something for later. But I think it's important that you get this overview of how requests and responses actually look like under the hood. So that was exactly the goal of this video. I hope the message was clear and that everything made sense. And so let's now move on and continue talking about backend development in general. So now that you have a good overview of how the web works behind the scenes, let's learn about what backend web development actually is and how it compares to front-end development. because this is a very important distinction in the web development world. So in order to distinguish between the front end and the back end of a website and of web development as a general, we still consider the same client-server architecture that we talked about before. So in general terms, front-end development is about everything that happens in the web browser. So it's about designing and building the final website that's going to be visible to the user, and therefore the name front-end. The front-end developer uses the basic technologies HTML, CSS, and JavaScript, which together form the front-end technology stack. Now, many modern front-end developers add more stuff to the front-end stack, like React or Angular or Redux or GraphQL or whatever is cool these days. So these technologies make front-end development easier, and all these technologies together that a developer or a team decides to use on the front end is their front-end stack, okay? And you probably already know most of this stuff anyway, but I still want to give you a brief overview of how everything fits into the bigger picture here. Alright, and now moving on to the back end, this part of web development is about everything that happens on the web server. So everything that is invisible to the final user, and therefore the name backend, okay? And since we're talking about the server side now, let's actually define what a server really is. Well, a basic server is really just a computer that is connected to the internet, which first stores a website's files like HTML, CSS, and images, and second, runs an HTTP server that is capable of understanding URLs, requests, and also delivering responses. So this piece of HTTP server software is what actually communicates with the browser using requests and responses. Therefore, it is like the bridge between the front end and the back end of a website or web application. Now, a simple web server like the one I just described is called a static server, because all it can really do is to serve static files to the client via HTTP. If you just need to host a simple website, then this is really all you need. But if you want to take it to the next level and create dynamic web applications that talk to databases and all that good stuff, we use a server that is also capable of running our dynamic applications, just like the code that we wrote and executed in the intro section of the course. This is then called a dynamic server, where we have our app running, an HTTP server, and of course the files all talking to each other. And in some cases, that's all we need for our applications. But usually, when we build dynamic websites or apps, we will also use a database, which we can access right from our applications. By the way, if the term static and dynamic websites or applications are a bit confusing for you, no problem, we will talk about that right in the next video. Anyway, we can use the database to store stuff like users, or application data, or text to fill up a website template. In any serious application, there will always be a database, and our backend code will communicate with that database. So some usual stuff that is handled on the backend, or the server side as we can also call it, is to create user profiles, perform logins, send emails, handle payments, retrieve and send requested data from a database to the client, manipulate data in the database, fill up website templates, and so much more. And we will do many of these exciting things throughout the course. Actually, all of them really. Now, about the technology, as you can guess, we are going to use Node.js as a dynamic web server and MongoDB as our database. So that is our backend stack. But there are so many different backend technologies and stacks available for the backend. Things like PHP with a MySQL database, or Python with a PostgreSQL database, or some people use Ruby on Rails, maybe with even some other database. But since you want to learn Node.js, well, we're going to use exactly that. And the most popular database that is used with Node is without a doubt MongoDB, and so that is our choice for our back-end stack. Now you might have heard the term full stack before, and that simply is the front end plus the back-end stacks together. So a developer that does both front-end and back-end development can call himself a full stack developer. But these developers are getting increasingly rare, especially because the front end is becoming more and more complex these days. Finally, another thing that I wanted to quickly mention is that, as you can see, we're going to use Node applied to backend web development, and not something like hardware programming. So you can technically use Node for stuff like flying drones, programming robots, or developing software for IoT devices. But that is outside the scope of this course. If you want to program IoT devices with Node, well, this course is still going to be useful for you. It's just not the focus of the projects that we're going to build. Okay? Alright, and I guess that summarizes the difference between the front-end side and the back-end side of web development, so that going forward, you have a good idea of the domains where Node.js is actually used in the real world. In the previous lecture, while talking about the front-end and the back-end, I mentioned simple and static and dynamic websites or applications a couple of times, but without really defining what they are. So in this video, I wanted to clarify these things and also talk about APIs in order to bring all these concepts into the bigger picture of backend web development in general. So let's start by talking about static versus dynamic websites. So a static website, or a simple website as I called it in the last video, is when a developer uploads the final ready-to-be-served files of a website onto the web server. These files usually contain HTML, CSS, JavaScript, images, and more. And as I said, these are the exact files that the server will later send to the browser when the website is requested. The browser will then take these files and render them as they are. This means that there is no work done on the server, there is no backend code, and there's also no application whatsoever running. Okay? So it's just a static web server serving static files, exactly like I mentioned in the last video. Now you might think, wait, when there is JavaScript on the page, then there are usually dynamic effects, like animations and stuff, right? Well, that dynamic that you mean there is a different dynamic. It's just in the context of front-end development. In the broader context, dynamic has nothing to do with effects on the page or things moving around, but with the way websites are generated on servers. Okay? So dynamic websites are different from static websites because they are usually built on the server each time a new request comes in. So like we saw in the last video, dynamic websites usually contain a database. Then there's also an application running, like a Node.js app, which fetches data from the database and then together with a predefined template, builds each page that the user requests dynamically based on data coming from the database. So each time a browser requests a page, that page is then built as HTML, CSS, and JavaScript files, which will then be sent back to the browser. This whole process is sometimes called server-side rendering. So again, that's why it's called dynamic, because the website can change all the time according to the content that's in the database or users' actions on the site. For example, if you're logged into Twitter, it will show you a completely different page than when you logged out, right? And it will also show you a different page tomorrow than it did today, because there are new tweets, so new data in the database. And that is what dynamic websites are all about. Now, if you, for example, go to jonas.io, and you should, by the way, then you will always see the same content, the same website, no matter when you visit or what you do there. And so that means that it's a static page. All right? Does this difference make sense? Now, sometimes we use the term dynamic websites and sometimes the term web application, but they are kind of the same thing. Usually when people refer to web applications, they mean a dynamic website with some functionality like logging in, creating user profiles, searching for stuff, and things like that in general. Websites are, for example, something like a WordPress blog. They are still generated dynamically, but we can't really do anything but reading them, right? And traditionally, static and dynamic websites were the only two types of websites. But in recent years, thanks to how powerful browsers have become on the client side, we see more and more websites that are basically based on APIs. So let's learn how these work and how we can use Node.js to power them. Let's just keep the dynamic websites here in this slide so that we can better compare the two. So Just like with the dynamic websites, we have a database here, and we have an app that fetches data from the database each time a client makes a request. So in that sense, a API-powered website is actually quite similar to a dynamic website. So both work dynamically. Now, the big difference here is that with an API, we only send the data to the browser, usually in the JSON data format, and not the entire website. So again, just the data is sent to the client and not the ready-to-be-displayed website. So no HTML, no CSS, only the JSON data. Alright? So when building API-powered websites, there is always these two steps. Building an API and then consuming the API on the client side. And by the way, API stands for Application Programming Interface. And on a very high level, it's basically a piece of software that can be used by another piece of software to basically allow applications to talk to each other. And we will talk a bit more deeply about what an API actually is once we start building one. Anyway, now about the client side I just mentioned. So this is where the website is then actually assembled by plugging the data that we receive into some sort of templates, usually using some fancy front-end framework like React, Angular, or Vue. I'm not going to go into specifics here because that would be for a front-end course, but in very general terms, this is how it works. So you see that when building an API-powered website, the building phase of the website kind of moved from the backend to the front end, right? Or we can also say it moved from the server to the client. That's why many times you will see dynamic websites being called server-side rendered because they're actually built on the server. On the other hand, API-powered websites are often called client-side rendered, which makes sense, right? So for us backend developers, it's actually far easier to just build an API and let the front-end people build the site, right? And in fact, Node is an absolutely perfect tool for building APIs, and it's very commonly used for that. But of course, it's also perfectly suitable to build a dynamic server-side rendered website. So in this course, we will actually do both versions, starting with the API, and by the end of the course, also building a rendered website using the exact same data. I chose to do both because I believe it's extremely important for you to know how to build both an API and a server-side rendered website. And now just to finish this video, I wanted to quickly mention that the APIs that we build with Node, or really any other language, can of course be consumed by other clients than just the browser, which is a huge advantage of building an API instead of a server-side rendered website. So let's say we build an example API on jonas.io/API/myCourseData. So whenever we hit that URL, the server will send back data about the web development courses that I am currently teaching. Now, so far, we only talked about requests coming from web browsers, but we could also request and then consume the exact same JSON data on a native iOS app, or an Android app, or even on desktop apps for the Mac or for Windows computers. The possibilities are really endless when we build an API, because we simply have one data source which can then be requested and used anywhere, not just browsers. That's kind of the problem when we build a normal dynamic website. We return HTML and CSS and JavaScript files, and only browsers can really understand these. So we're then trapped into that single platform. And that might not be a problem in many cases, but for complex products that require a lot of apps and websites and web apps, usually an API is always needed. So in this example on jonas.io, I could build this API and then build an API-powered website and some apps and get my data on all these clients from just one source. All right? And some people or teams don't even have any client of their own at all and simply sell access to their API to third parties who will then consume these APIs and not their own. So there are really entire businesses built around this philosophy of just selling an API to other developers or companies. Anyway, I hope that with this final slide, the concept and reason and kind of philosophy behind building APIs now became crystal clear to you, So let's now move on.